Okay, hi guys, how you doing? So Mrs. Johnson here again, and today we are going to review lesson 0.4, which is simplifying algebraic expressions. So here we go. Okay, so I've got my handy dandy notebook right here. I've been trying to keep up on my table of contents, so I'm just going to go ahead and add this one in, 0.4. Simplifying algebraic expressions. And that's going to be page 4. Okay, so I go to my page and I kind of already got this started. So I have my title of my lesson, 0.4, Simplifying Algebraic Expressions. And then I've got the essential question. How do you simplify an algebraic expression? And anytime I come across a question like this, because we don't necessarily have a set list of vocab words, we just kind of know based on our lesson right here, what do you need to know the definition of in order to be able to understand this lesson. So the first thing I see there is I need to know what it means to simplify. And I know I talked about it in 8th grade. I'm sure your other teachers have talked about it as well. And there are a lot of different ways to think about simplifying or to simplify. A lot of people think it means to make something smaller or shorter or less terms. And there's a lot of different ways that we can describe it. My favorite definition of simplifying or simplify that I've ever seen is to preform all possible.
Thomas, can you please call the office? Thomas, call the office. Thank you.
It's just like being in school. Operations. Okay. And as you guys have learned from previous lessons, an operation, that's your add, subtract, multiply, divide. It's also going to be part of your exponents. That's also going to be one of your mathematical operations that we're going to be working with this year. But to perform all possible operations. So as we're looking at our expressions coming up, you're going to see how there's some operations we can do and some that we can't. And that's how we simplify. Our other word that I see there that I need to know the meaning of is, what is an algebraic expression? And an algebraic expression is a mathematical. We can also really think of it in terms of algebraic. Remember, algebraic meaning it has variables, it has unknown values. Sentence or phrase, we're going to call it a phrase. A sentence to me has an end and a period, and so it would have an equal sign, and expressions we know don't have equal signs because we don't know the actual value of it until we give it more information. So a mathematical phrase containing symbols used in algebra, like one or more numbers, variables, and or arithmetic operations. And that is our vocab. So essentially what we're going to be learning to do today, or reviewing to do today, is how to perform all possible operations when we're giving a mathematical phrase containing one or more numbers, variables, and or arithmetic operations. Okay, so there is my vocab. Now, there are going to be a couple of things that you're going to have to do and you're going to have to know when you're simplifying. And the first one is, when we are simplifying algebraic expressions, it's what to do if we need to evaluate an expression. So remember, evaluate means to find the value of. So let's say I have the expression x squared minus 2x plus 5. And right now, I can't do anything with that because I don't know what the value of x is. And there's no equal sign, so I don't know what the value of the entire expression is. So at this point, I can't simplify it. I can't do anything with this. But what if I tell you that x equals -3? Well, now that I know the value of x, I can plug that in. So my next step, I'm going to use a different color so I can kind of show the substitution. Everywhere I see an x, I am going to put a -3. And I always put it in parentheses so that I can kind of show that that is the value that's being substituted and it's being grouped together. The -3 squared minus 2x plus 5. Now I'm going to follow order of operations. Remember, we did that the other day, the gems. And I'm looking for grouping symbols. And right now, the only thing being grouped is my negative and my 3. So I really don't have to do anything with that other than knowing that it is grouped together. So I'm going to go to my e exponent, and I see right here, I have a -3 squared. Remember, a -3 squared is a -3 times a -3, which would be a +9. And I still have the rest of this. I don't see any other exponents, but I do see right here, I see some multiplication. So I'm going to go ahead and multiply those together since there's no exponents that are affecting them. And essentially what I have right here is -2 times -3, which would be a +6. And then I still have my +5. So that takes care of my E and my M. I don't have any other division. And now I'm to my addition and subtraction. And right now I see all addition left to right. 9 plus 6 is 15. 15 plus 5 is 20. And my final answer to that expression when I substitute -3 in for my value is 20. And I could do the same exact thing if I had multiple values and multiple variables and multiple values for those variables. So for example, if I had 4a minus 3b plus 5c, when a equals 1, b equals -5, and c equals 3. And from there, I can plug in a 1 for my A, a -5 for my B, a 3 for my C. Everything else stays the same. And now all I see here is multiplication and addition and subtraction. So I'm going to do my multiplication first. 4 times 1 is 4. -3 times -5 is +15. 5 times 3 is another 15. And I end up with 15 plus 15 plus 4, which we all know is 34. So we have a couple of different examples there of what to do when we're told to evaluate. Okay, the next thing we're going to talk about is how to simplify if we have like terms. Remember, like terms are must have the same variable raised to the same exponent. Okay, so let's start with the example. Oh, this one's a good one. 6x to the 7th plus 4x to the 6th plus 9x to the 7th plus 3 plus 2x to the 6th. Now, I'm a very visual person, and I like to kind of break things down and make them a little bit easier. So anytime I'm looking for like terms, I like to use either you can use different colors or you can use different shapes to just organize them. But I'm going to start by going through and looking at my powers. So I have an x to the 7th here, and I have an x to the 7th there. That means that I can combine both those x to the 7th. They are like terms. I have 6 groups of x to the 7th. I have 9 groups of x to the 7th, which means in total, I have 15 groups of x to the 7th power. I'm going to start looking at my next term. It looks like here I have 4x to the 6th, and I continue looking, and I also have a 2x to the 6th. So same idea, 4x plus 2x to the 6th is 6x to the 6th. And then looking a little bit further, I see I have a lonely, solitary little 3. Can't combine it with anything. It doesn't have any like terms, and we are done there. Now, once again, remember, simplifying means to perform all possible operations. So as I look through this, I see that I have no other x to the 7th, I have no other x to the 6th, and I have no other constants. So at that point, that is simplified. And since I don't know the value of x, this is as far as I can take it. So I don't normally write on the back of my pages, but since this is all part of the same lesson, I'm going to go ahead and just move to the back side. Once again, if you don't like to see the bleeding, you're welcome to use the next page. The last thing we're going to talk about today is distributing, or the distributive property, distributing. Okay. And remember, distributing is basically when you have a multiplication of something in parentheses, of an expression in parentheses. Okay. So for example, let's say I had 2x times 7x squared minus 9x plus 3. Okay. And so this is what's inside my parentheses, and I'm distributed. Now, according to order of operations, we would do what's inside the parentheses first. The problem with this is that I don't know the value of x, so I don't actually know the value of what's inside the parentheses. That is why we use the distributive property. So remember, when you use the distributive property, you multiply everything inside the parentheses by the value that's outside the parentheses. So ultimately right here, I have 2x times 7x squared. And then I have 2x times negative 9x. And then I have 2x times 3. Okay. Now I can do these since they're multiplication, and you guys learned this last year, and we'll review it here in a little bit, but I'm just going to tell you right now. Remember, anytime you are multiplying powers with the same variable, you add the exponent. So that x to the, or 2x is like having 2x to the first. So I'm going to actually add those together to get x to the third. And then 2 times 7 is 14. And then here I have an x to the first and an x to the first. So that's going to become x to the second. And then I have 2 times negative 9, which is going to be negative 18. So that's going to become a subtraction. And then here I've got x to the first and nothing there, so it's just going to stay in x. And then 2 times 3 is 6, and since that 6 is positive, that's going to be an addition. And now I have no like terms because these all have a different exponent. I don't know the value of x, so that is as far as I can go. Now, I know I said this last thing was last thing, but this, I have one more thing to tell you guys about. And that is sometimes you're going to have to do a couple of these different ideas when you are simplifying. So let's say I have this problem. I've got 5, and it's multiplying the quantity of 3x minus 4y. And then I'm going to subtract 4 times the quantity x plus 7y. So we're going to simplify this. And the first thing I see I'm going to do here is I'm going to distribute the 5 because it's outside those parentheses, and I'm going to distribute to those ones. So 5 times 3x is going to give me 15x. 5 times negative 4y is going to give me negative 20y. So this first distribution is taken care of. Now I'm going to go to the second one. Notice out here there's a subtraction sign outside that 4, or in front of that 4. That really basically means that is a negative 4. So I'm going to distribute that negative 4 to everything. So I've got negative 4 times x, which is negative 4x. Negative 4 times 7y is negative 28y. And I'm good to go there. So my distribution is done. The next step I'm going to do is now see if there's anything to combine. So right here, I see I have a 15x and a negative 4x. Remember, the sign in front of it tells you if it's positive or negative. So 15x minus 4x is 11x. And then I see next that I have negative 20y minus 28y. And that's going to give you a negative 48y. And then since they have different variables, I don't know the value. I'm done. So when you are simplifying, this is what I recommend you look for. First of all, see if there's any values you know so that you can evaluate it. If you don't know any values, you're then going to see if you can perform other operations like the distributive property. And then from there, see if there's any like terms you can combine. Okay, so these are going to be what I call your look-fors. Okay, have an awesome day.